ChatGPT a question. Okay. You say, AI bro, how much did we make last year? And if you ask a normal ChatGPT that question, it will have no idea what you're talking about. But you build this chatbot so that it can query from your company's database. So the ChatGPT will ask your company's database for that information. It will come back, and then the AI will use it to make an answer. Your company made $5.50. Ooh, not good. So how does this work? We're going to talk about something called embedding, which is basically just taking a word or a sentence or even an image and putting it somewhere in space, giving it some coordinates. So let's say we put the word cat over here. This is a three-dimensional space right here. We've got the Z, got the X, we got the Y. Okay, so we put cat right there. Then maybe computer is way over here. And they're far away because the concept of computer and cat, they're not related. So they're far away in space. And then maybe rice is down here because that's really far away too. But dog is pretty close to cat because they're both house pets. So they're pretty close together in space. Then military, is way up over here because it's not related to any of these concepts. And then maybe beans is pretty close to rice because they're often mentioned in the same sentence. So then what we do is we give coordinates to each of these words. So for example, cat, if we look on here, we go up to here, we go down here. And then so on the x-axis, cat is 1.5. And then we see on the y-axis, okay, cat is probably around 5. And then on the z-axis, it looks like cat is around maybe 50. So that's our coordinate system. We locate words in space. So this is 3D space, but vector space has a lot more dimensions. Vector space has hundreds and even sometimes thousands of dimensions. So if we are trying to visualize vector space with thousands of dimensions, we cannot. Humans cannot do this. We cannot visualize this because we've only ever experienced, 3 or 4 dimensions, right? Fourth dimension is time. So, this is all we've ever experienced. So we cannot visualize a vector in thousands of dimensions, but computers are really, really good at that. So that's what we do. It's called embedding, where instead of doing, finding cat's location in 3 dimensions, we do it in hundreds or thousands of dimensions. Why would we do this? The reason why is because you can find similar concepts even if you don't know what keyword you're looking for. So for example, in a traditional keyword search, you have to know exactly what the word is. Like if you are searching for computer, but you use a different word, if you use like electronics, the word computer will not show up because it's a different word. Or if you're searching for beans in a traditional search, rice will not show up because even though it's a related term, it's not the exact same term. Keyword searches search for the exact words. Vector searches are kind of a little bit more fuzzy. They search for concepts. So let's say that you query something. In a normal database, a keyword database, if you said, I'm looking for an animal, all it would return to you is the word animal, and that's it. But this is a vector database. So we align things by their meaning, right? Similar terms have similar meanings. So if we enter a query into our vector database, I'm looking for an animal, then we vectorize this, we embed this, create coordinates for this sentence. Those coordinates might be right there. So we're looking for an animal, and then the coordinates for that sentence, when we turn it into a vector, are right there. And then that helps us because then we can look at the closest concepts to that query, which would be cat and dog. So I'm looking for an animal, and then we see, oh, these concepts are very close. So these are the closest queries. These are really good matches for that query. Whereas if it was over here, rice and beans are not a good match for animal, neither is computer, neither is military. So now we're going to talk about chunking. So why would you want to divide documents up into chunks? So let's say you have a really long document. Let's say you have the Constitution and you want to get some information out of it. Why would you want to divide that Constitution up into chunks instead of feeding the whole thing to AI? And the reason is ChatGPT can only understand around 32,000 words before it starts to forget things. And this is kind of a complicated explanation. It goes along with the architecture, but it's just basically a limitation that we have to work with for now. So you cannot put in like the whole Constitution because it's much longer and you won't get a good response out of it. It won't understand the whole thing. Also, reading things and writing things from ChatGPT can get very expensive. So if you're using the API, it costs 3 cents for every 1,000 tokens. Token is like part of a word, and it costs 6 cents for every 1,000 tokens that you generate. So reading costs 3 cents, generating costs 6 cents. So it can get very expensive, especially if you have this huge long document. That's a lot of money just to read one, especially if you're doing this all day with a lot of different customers. So the rule of thumb is you got to have a balance. You got to make the chunks small enough that you're saving money, but big enough to contain useful information. So it depends on your situation, but 600 to 1,200 characters is a pretty good rule of thumb because they're long enough to be containing good information, but they're short enough to be short enough that ChatGPT can understand the full text snippet. So, but like I said, it really depends on the situation. So for example, we were talking about your company's income. So this would be really bad chunking right here because it's too short. Our department has an annual income of, and then chunk two, $40 million, which is phenomenal. So this would be really bad because if you are doing vector search, like we said before, this chunk would show up. This chunk would be queried, or you would query, our company's income, and this chunk would show up, but this chunk would not. This is kind of the tag. It's what the information has that will be queried. And then this is the actual information that you wanted. And so it would be a lot better to have those in the same chunk because then they would both be returned and your AI would be happy. Whereas if this gets returned, your AI will still have no idea how to answer the question. So this is better chunking. A whole idea is in one chunk. Enough meaningful information for the AI is in one chunk. Our department has an annual income of $40 million, which is phenomenal. So if you searched for annual income, you would get this, the annual income, and you would get the answer. Okay, so there are many tools available to help with chunking, including LangChain. LangChain is designed specifically for Retrieval Augmented Generation, and also NLTK, Natural Language Toolkit. So here's a little bit of an overview of how this works for changing your text into vectors. We all know that OpenAI makes ChatGPT, but they also have an API that you can send anything to, and it will send you back a vector. It's called ADA002. So you just send your text to that API and you get a vector back. And it doesn't have to be text. It can be like images or kind of any data you want, and it embeds them in vector space. And the texts or the ideas that are similar to each other will be close in space. And then there's a particular thing called a vector database, which is designed to store vectors and search between them. One of them is called Pinecone. It's free to use. It's not the best vector database. I don't recommend it, but it's really easy to set up and it's free. So it's a good way to learn. They delete all your data after 1 week, just to know. Okay, so we can look at the Pinecone code in a little bit, but here's an example of how the prompting works. So we said, okay, here's the question. The user would enter this into your chatbot. How much did our company make last year? But your chatbot doesn't really know the answer to that. So what you would do is you would run it through your own program and you would say, please use the chat history, if there was any chat history, and the user's question to create a query for a vector database that will return information to answer the user's question. So you're using ChatGPT to generate a query. You don't have to do this, but I find it to be very effective. So you take this question, you tell ChatGPT, hey, please give me a query for a vector database relating to this question. ChatGPT sends the query back, and it looks like maybe 2022 income statement, right? So that's the query that you're going to use on your vector database. So you send this to your vector database, and then your vector database comes back and says, okay, this was the closest thing we found. We made $4 million, and it'll give you the name of the document. If you put that in your vector database, you put vector, text, and the name of the document. So you get this back, and this is the answer. So then you tell ChatGPT, you say, okay, here's a question. Here's our information to answer it. Now I would like you to put these two together and I would like you to give me an answer, like a well-formed, beautiful looking answer that doesn't have all this extra information. I want it to look pretty. I want it to look like a conversation because that's what people like. And I also want you to tell me what your sources were. And then so ChatGPT will come up with this cool phrase and it will say, last year in 2022, your company made $4 million. So that's just the combination of the question and the information and this prompt that you sent saying, please make a nice answer to this question. Okay, so that was, let me see, it's a little bit short. So I am going to show you guys the notebook. Let me see, where is it? Brag demo. Okay, this isn't a complete demo. It's just kind of an overview. And it's loading. Okay, while that's loading, we can take, oh, there we are. Okay. All right, so this is a Colab notebook. It's free. You just sign up for it. You just have to have a Google account and you can run code on it. And you can also use a GPU if you want to for training an AI, an AI program. We won't be doing that. We're not training an AI program. We're just uploading some vectors to a vector database. So what you do first is you download the text that you want right here, and then you install Pinecone client. Pinecone is that vector database. Oh, see, here we are. So you can change the runtime type. You can choose any kind of GPU you want. You can change it to hybrid. All right. For some reason, it's running very slowly. So here is Pinecone. This is the vector database thing that we talked about. And see here, words and ideas expressed in 3D space like that. So this is pretty easy. You start it, you log in, and then you get like some passwords and keys. Very strange. It's running very, very slowly, and I'm not sure why. Okay, I'm going to try to log in. Okay, so now what you do is you create an index. Let's say text index. Oh, text index. Index just means database. Dimensions, we're going to use 1536 because we are pulling from, we talked about ADA 002, and that one has 1,536 dimensions, and the metric they use is cosine. So you can just read that on OpenAI's webpage, and you do starter, which is free, and free tier index, and then you just create an index. So we do create index right there. See, pretty easy. Now we've got our index. So that's our environment. And let's see, connect. Oh, it says initializing. So it's not entirely done yet. But when it is done, I can take host, and there's also like an API key, I think, that we need. So after I download some text and I install Pinecone client, which is the Python version of what you need to connect to Pinecone, you install OpenAI, and you make an account with OpenAI as well. And you get your API key. That's what this cell is. And then this is how you set up your connection to your Pinecone database. You have to have your API key, environment, and index name. So let's go back here. It says initializing. So there's my environment. I'm going to copy that. Environment, paste. API key. See where I'm not even sure if it has one yet. It's still initializing. So let's restart that again. Still initializing. So there was, and text index is the name. So text index. Okay, so I think I still have to wait to get the API key. API key, there we are. Okay, that is the API key for Pinecone. All right, and API key right there. Okay, let's see if it can connect. It might not because it's still booting up. All right, let's try that again. Yeah, it's still initializing. So if we would, oh, you know what? It just turned green. Let's see if that one works now. All right, good. Okay, so these are some statistics that describe our database. We have 1536 dimensions, like 3 dimensions versus 1536 dimensions. Index fullness, we have nothing in there. Namespaces, I'm not even sure what that means. Total vector count, we don't have any vectors in there. This is kind of an example of the format that you might want to use. You can use like a string and then the vector, right? So you just do index.upsert, a list of tuples, a string, and then a list of numbers. This is just, I just keep this here to remind myself of how to do it. Okay, so then we want to install LangChain, OpenAI, TickToken, and Pinecone client for gRPC. All right. So then it looks like I already installed. Okay, so I downloaded this text earlier. Okay, that's probably fine. So then I'm going to open my text file and read it into a variable. Then I'm going to print out some of it. All right. And the earth was without form, darkness void upon it. Great. So this is the part where we actually embed our text, right? So we do OpenAI embeddings, model name equals model name, and it was ADA002. OpenAI key equals OpenAI key. And that's one that I put in earlier. So what we do is, let's do line. Okay. So this will actually embed things for us, but this will first split it. This is going to split things. Like we said before, we have to put things into chunks. We can't just put the entire Bible into one embedding because it kind of doesn't convey enough information. Remember, we only have 1,536 dimensions. And if we've got millions of words, then that's not going to be enough information. That vector is not going to be enough information to represent all those words. But if we have like 100 words, then yeah, that vector would probably do a pretty good job. So we're going to say maybe 400 characters, chunk overlap. So chunk overlap is like, if you want the words before the sentence and the words after the sentence to give it context. And you can do that. You can do that or not. It's kind of up to you. You do some trial and error and figure out what gives you the best results. So then we would do text splitter .create documents, and then it would, convert them into chunks. And then we would do embed documents. So for each chunk, we would embed it. We would take a chunk of like, maybe 400 characters, which is a couple sentences. We would turn that into a vector and it would put it somewhere in vector space. Then we would take the next chunk, which is like, 400 characters, and then we would put it into vector space. Put another one into vector space, another one, just over and over until we have this entire document, the entire Bible in vector space. So for example, we're also creating IDs just because, it helps to have an ID for each vector. So then we have, let's say we upload the first verse of the Bible. We would upload it. We would first convert it into an embedding. See this vector? This is what a vector looks like. First dimension, second dimension, third dimension, fourth dimension. And then
I
after,
have a few questions.
yes.
Sorry to interrupt.
No
Yeah,
problem.
there's
Yeah.
one. Yeah, there's one. Are there any dimension-based restrictions when storing data to the vector databases?
So, what was the question again?
Are there any dimension-based restrictions when storing data to the vector databases?
Okay, so dimension-based restrictions. I'm not sure what you mean.
Um, Not really sure here. Maybe you could elaborate a bit, Deepak. That would help. There was one more though. Curious how text and images get converted to vectors and embeddings in vector database.
Good question. So they're run through an AI model. They get run through often like an open source model is called BERT, which is one that you can just download. And I think it has around 700 dimensions. And you just put text or you put an image through that, and then it spits out a vector. So AI, that's just the answer. As far as uh, dimension-based limitations, I've seen some databases where you have to pay based on the number of dimensions. Like if you have, if you're uploading vectors with 1,000 dimensions, then you have to pay a lot more than if you're uploading vectors with only like 1 or 2 dimensions. Okay,
Right.
so, all right, so then we create these vectors. We have an ID, then we have our vectors, and somewhere, way down there, 1,000, 536 items down the road, we have the text. So we have the ID, the vector, and we have the text. And we created those using our code, embed documents. Then we create a dictionary, Python dictionary, where we have ID and values and text, and we can have some metadata if we want to. And then we do index.upsert vector dict. And so we upsert those into our Pinecone database. Upsert just means, we send it to the database. Then after that, we're not done yet because we want to do a query. And like I said earlier, if we want to do a query, what we do is we take a string like this. We take, give me a verse about loneliness. And then we embed that query. We take this query and we turn it into a vector as well. So then what we do is we send this to Pinecone and we say, hey, Pinecone, this is a vector. I want you to give me the 3 closest vectors to this one. We can choose how many we want. We can be like 30, we can do 3. The higher number you choose, the longer it takes. But 3 will probably be enough. Like 3 to 5 is usually enough for retrieval augmented generation. So let's say we tell Pinecone, give me your 3 closest vectors to this vector that I just sent you, which is the query vector. So it will pull back 3 vectors with their text. And it'll say, okay, I think these 3 are the closest. And it'll be like, 3 Bible verses about loneliness. And then you send those off to ChatGPT. You say, here's the user's question. Here are 3 pieces of data. I want you to use these to answer that question. You are a chatbot. Please use the following information to answer the user's question. And then the vectors. If you cannot answer the question using the given information, just reply, I don't know. Only answer using the provided sources. It's important to say that because you are setting it up for what you want it to do. Retrieval Augmented Generation also combats a problem with LLMs called hallucination. Sometimes you will ask a question of ChatGPT and it will just flat out make something up. And that's just one of the problems with AI, is that it sometimes makes things up. And so if you have a prompt like this saying, if you cannot answer using the given information, just reply, I don't know, only answer using the provided sources, that helps combat hallucination because you are giving it some short information and you are saying, here's the question, please answer this question based only on this information. Whereas if you ask it, like an open-ended question without answers, it's probably gonna hallucinate. It's gonna make stuff up. All right, so yeah, so that's basically the vector and query process and how to store them as well. You can also use things to upload many pieces of text to Pinecone. You don't have to just upload the vector and the text. You can upload a lot of other information too. Like you can upload the date. You can upload the question and the answer. You can upload the person who wrote it. A lot of different interesting data that you can attached to one vector. But you want to make the vector an embedded version of the thing that you want to search by. So if we want to search by the context, we want to search by the text, then we would embed that. And if we want to search by the author name, then we would embed the author name. Okay, Shibata Pawar raised the hand. You have a question?
It'd be great if you could write it on the chat, Shubda. Uh, all right, you could even ask it out loud. I guess that was by mistake. We can continue.
All right.
Hello.
Oh,
Sorry, I
hello.
was not able to unmute myself. My question is like using this database, vector data space, does it provide any information security at company if I'm using this? If I want to implement the idea for this in my company, then?
No, that's a good question. It does not implement any security. So if you wanted, I know exactly what you mean. Like let's say you have two chatbots. One chatbot is for your customers to access, your product data. And you have another chatbot that is for your CEOs to access financial data. And you do not want your customers to know your financial data, right? You would have to create two different indexes, and you would have to have one index with your financial data and one index with your customer data. Or another option would be to set some kind of a parameter where, like in one index, there would be customer data and there would be financial data, and the customer data is tagged with something that says customers only. Financial data is tagged with something that says financial data. And you could, from the front end, when a customer queries, when they say, give me information about this, you have some code that will only return the customer data. But even that, I would feel a little bit sketchy about that, about putting private information in the same index as public information. I'd feel, a little bit strange about that. So I would recommend having two different indexes if you have
Okay.
private data.
Okay. Though I have a different indexes, any person from outside company can access if he has the same query to ChatGPT.
I'm sorry, say that again.
If any person outside the company try to ask the same query, can he also access that data? That is my main question. Yes,
Uh,
yeah.
only if you allow them to. So for example, if we have a database full of private company information, only the people that you give access to that data would have access to it. So let's say you have an internal chatbot, right? Your internal chatbot can connect to that company data, right? And ask questions of it. So you want to make sure that that chatbot never falls into the wrong hands. You want to make sure that you have tight security on it. You have logins, you have, passwords, whatever's needed to make sure that only people in the company can access that chatbot. Because you're right, if somebody outside the company ever accessed that chatbot, they could get all the information they want about the company's finances.
Okay. And the one last question is can I customize the current Open AI chat GPT, or I do have to create my own chat GPT for this?
Oh, good question. You do not need to customize OpenAI's ChatGPT. You do not need to create your own. ChatGPT
Oh,
is already perfect for this. All you have to do is just come up with a prompt. All you do is say, here's the user's question. What were our finances from last year? Here's some data. And then you say, some finances that you pulled from the vector database. And then you say, please use that data to answer that question. And then it will return an answer. And then that answer is what you show to the customer.
okay. Okay. Yes. I got all the answers. Thank you. Thank you. Yeah.
Okay, no problem. All right, that is all that I have prepared for today. So let me know what questions you guys have.
The questions have started coming on chat now.
Okay.
Yeah, what challenges arise when it comes to productionizing this type of application, and which tools or frameworks would you recommend to tackle these issues effectively?
Well, that is a very good question. So um, the biggest problem that I've found production wise is that people don't really understand how it works or how to use it. So for example, I had somebody ask me, please give me a summary of all of our finances forever. And that's not really something that you can do with this because, as I mentioned, you can return like 3 pieces of information. You cannot return all of the pieces of information and ask the AI to make sense of it. So that's one problem that I've had. Speed is another problem. Sometimes when you ask a question, it'll take up to like 15 seconds to query your database and then get back. So that's a little bit difficult. Let's see, frameworks, just ChatGPT. I also like using, what's it called? Azure Cognitive Search. So one thing that I didn't mention is that there's keyword search, right, which is the old way, and then there's vector search, which is the new way. But searches work best when you use both. So if you can find a database that can use both, like I think Pinecone can use both, and it's called hybrid search, and DataStax can use both. There are a couple other ones like Weaviate, they can use both. So it's good to be able to do a hybrid search. And as far as like frameworks go, I don't know, you can use LangChain. LangChain works, or you can just write it yourself. I find it simpler to write it myself. Yeah. Uh, okay. I hope that answers your
Yeah.
question, Arpit.
Yes.
Black and
I believe, yeah.
okay, blacken the indexing if it doesn't match to free up nodes. Blacken the indexing if it doesn't match to free up nodes. Is it so? I don't understand the question. I'm sorry. Intel has
Ravi, if
own Intel has own AI optimization tools for frameworks. Okay, that's good that Intel has those. How secure? Oh, great. You're welcome, Arpit. How secure is it to upload crucial financial company data and stored in databases like Pinecone or MongoDB? I guess it's you would have to talk to them. I don't know. They have their own security. I think it depends on how you manage your passwords and your keys. So, I mean, as long as you keep your API key secure, it's probably fine. Can I get a recording of this session? That would be a question for Shreya.
yes. Yes, Sunil, as I mentioned in the chat earlier, you guys will get the recording of these sessions.
I have a fixed set of questions which I expect user to ask ChatGPT. How do I stop user from asking any random questions to ChatGPT? So Deepak, that is a very good question, and I wish I knew the answer because so when I was making my own retrieval augmented generation, um, I was given a list of questions by people at my company. It was like around 20 questions, and I fine-tuned my model until it could answer every one of those questions perfectly. And then when we did the demo, they asked me questions that were not in that list. They asked me questions that it could not possibly answer. And so, we gave them bad answers and they were disappointed. So it's kind of like designing user interfaces. Like there's a lot of jokes about how like you can carefully design a user interface and then a customer sees it and uses it for the first time and they will find the one way to like make it catch on fire and explode. Um, but I mean, one way to do it is you could give ChatGPT a list of questions and you could say, if the user's question is not in this list of questions, then please return, I'm sorry, I don't know how to answer that question. Or actually you could filter the person's question beforehand. You could say, these are approved questions. And if it's not in this list, you could just write a Python program to stop it and say, I can't answer that question. Or you could have the questions and let them click on the questions rather than entering their own. All right. Through this method, the data that flows through ChatGPT to give answers from company's database would open. Would OpenAI have access to it for training ChatGPT? That's a good question. I think it really depends on the way that you're using it. So up until now, ChatGPT has always had this policy where they say anything that you enter into our program, we can use it to train our program. They recently came out with something called Enterprise ChatGPT. So it's private, they say, and they will not use your data to train another model. So I think it depends on which version you use. Can we use other LLM like Llama 2 for this? Yes, you can. I wouldn't recommend it for professional purposes. I think that ChatGPT or GPT-4 is the only AI that I think is production ready. I've tried all of them, and GPT-4 is the only one that I would trust. What tools do we need to build our own ChatGPT? Do you mean training a model from scratch, or do you mean using somebody else's model and then chatting with it? Shabda? From scratch, that's beyond the scope of this. Training your own model from scratch. Okay, so GPT-4 costs around $100 million to train. So that gives you an idea. It's a pretty big process. Okay, does chunking affect short-term memory? Yes, it does, actually, Tanya, because GPT or a GPT model's short-term memory is very limited. So if you have long chunks, you're not going to be able to fit very many chunks into GPT's short-term memory. But if you have shorter chunks, then it's going to understand those a lot better. But then again, the problem is if you have chunks where you need the whole chunk to understand something, then you can't cut it shorter. So it depends on the text. Like if you are working with legal text, lawyers and judges tend to like really long sentences. So you may want to have really long chunks. Whereas, you know, something short like a product description, you might be able to have like really short chunks because it's like this product is made of silver. This product has a tolerance of this. This product is $35. You know, so those are very short chunks, and they all contain appropriate amounts of information that is usable. Okay. Connect. What makes an LLM capable for this, and how do we decide if it's capable? Good question. All LLMs are capable of this in some ways. So some LLMs can only take in 512 characters, which is very, very short, and you're not going to get a lot of information into that unless you want to do like one question at a time. Some LLMs have, you know, they can do 32,000 characters. So I would say the longer context window is sometimes better, but how do we decide if it's capable? You have to try it. You have to try it out and see. Try several different models using the exact same information. Like, you know, you could even just create your own prompt that says, here is a user question. What were our finances like for last year? Here is some data. You know, we made this much, we made that much, we made that much. Please use the information to construct an answer. Please only rely on that information. And then you can compare the responses from different models, from different LLMs. You can compare the response from GPT-4 to the response from Llama 2 to the response from BERT, and then just look through and see which one you think is the best. Okay. Where can we follow you for more content like this? Do you have a YouTube channel or something? I have a LinkedIn. You can just search for me, Tyler Seward. And I also have a YouTube channel. I don't post on there very often, but I post every day on LinkedIn. What if we use Node.js ecosystem to optimize better and blacken the rest? What do you mean by blacken? Blacken the index.bc of a single thread or individual schemas. I don't understand a word of what you said. Blackening the index. I don't know what that is. What if I want not to build from scratch GPT? Which tools do we need? Okay, so Shabda, if you want to take somebody else's model and then train it, that's called fine tuning. Which tools would you need? I think there's something called, there are a lot of them that just came out called like fine tune Llama or fine tune Llama 2. So I would look for those. Is it possible that I give user an option to choose a model from which he wants the answer? Let's say OpenAI, Vertex AI, or DALL-E, and let user choose the model he wants the answer from. Have you any case accounts of this situation? Yes, actually I have. You can do that. It's very easy to switch between models. You just pick which one you want. I think you can do that very easily with LangChain. I I wouldn't do that in production because usually people using the chatbots don't know anything about models. They don't know which one they want to use. And like I said, OpenAI GPT-4 is the only one that I think I would trust. Like I've tried all the other ones and I don't trust a word of what they say, but ChatGPT, when it says something, I trust it, at least in general. All right, let's see. Robbie, if you want to explain your question, I don't really understand what you mean by blacken the index, and I don't know anything about Node.js. So if you want to explain that question more, I'd be happy to answer it.
Ravi, if you could unmute yourself and maybe elaborate, it would be great. Well, I guess there's no question there then. Folks, we're still open to, yeah, there's one more now on the chat.
It says, okay, Vishnu Prasad said, is the parameters of an LLM correlate to how good it performs in these type of queries? That's a very good question. So Vishnu Prasad asked, I think, the number of parameters. So yes and no. Usually LLMs that perform well in this type of situation have been trained to perform well in this kind of situation. So like if you have a really huge model with, 100 billion parameters, that's going to be a really good model at everything. But if you have a really small model that's trained on a specific task, it's probably going to do even better than the big model on that specific task. But in general, more parameters is better. If we could get like a 10 trillion parameter model, that would probably be the best performing model, but it's hard to get a model with that many parameters because I think 20 kilobytes per neuron or something like that. So, but yeah, in the past, as as time has gone by, the more parameters we put on a model, the better the performance. I think GPT-4 it's like 8 different models. Each one has 220 billion parameters. Okay. Can embedded system face bulk code overflow? I don't know what that is. Embedded system face bulk code overflow. We're not working with embedded systems here. And I don't know what bulk code overflow is. I'm sorry. Is the transformers core algorithm all the same for all the LLMs? Ooh, that's a good question. No, I don't think so. I think GPT might be a decoder only, and I think BERT is encoder, decoder. I think they all have their own little flavors. They all have their own little twist. Blacken the array, which is useless to free up nodes, solid optimization. Okay, so Robbie, we don't have control over our AI. We don't have control over GPT-4. All we can do is send things to it and from it. We do not have control over the training. We cannot blacken nodes. We cannot optimize it. It's owned by somebody else. How do these parameters get decided? Do they collect manually? So the parameters are determined through training, and that's a different thing. You can look that up online, how to train a neural network. What path can we follow to learn AI and start building AI apps? That's a very good question. So there's a guy named Andrew Ng, Andrew, and his last name is NG, and he has a very popular course on Coursera. He has a couple of very popular courses, and he would be a good person to look into. Take those courses first because people usually like his material. All right. Question is a little off topic, but why couldn't they make ChatGPT dynamic like Bard? Why isn't ChatGPT up to date but only work on pre-trained data, not like the available data on the web like Bard? It's a really good question. I don't know. It is interesting to me that ChatGPT is still stuck in 2021. Like if you ask it, tell me about statistics from last quarter, it will give you statistics from 2021. So why isn't it updated? I really don't know. Bard is really bad. I think it's terrible. I've tried using it for coding. It is always wrong. So, okay. Yeah, deeplearning.ai is Andrew Ng's teaching website. All right. You have
Great.
a couple.
So, wow, that was a lot of questions. I guess this is a very interesting topic. People have many questions.
Yep. Yeah, and Shubham said, yes, you can use web plugins with ChatGPT. Yes, there are a lot of them. Like you can read PDFs, you can design diagrams. It's pretty good. How does one specifically train an LLM for this? So you do something called fine tuning, where you would fine tune it on retrieval augmented generation tasks. What you would do is you would have a data set of around like 50,000 things where this is your input. So it would be like, this is the question, these are the 3 pieces of data, this is the output. So Piyush said, what path should we follow to learn AI? Like I said, take Andrew Ng's courses on Coursera or go to deeplearning.ai. Sahil put that link up there. Andrew Ng is a very good teacher, and a lot of people really like his courses. So that's a really good way to start learning about AI. Another way is there are a lot of newsletters, a lot of AI newsletters that talk about the most recent research in AI. And that's a good way to learn, what's cutting edge right now.
Great.
You're welcome, Piyush.
All right, folks, we can take like 1 or 2 more questions. And in the meantime, you can also let us know how you've enjoyed the session so far. You can fill out the
Welcome, Yash.
feedback form. And yes, you can definitely put it out on chat box for Tyler to also see how you guys are enjoying the session. I believe he's been very patient with your questions, taking all of them. But yeah, you can let me know on the chat as well.
You're
Okay.
welcome. Thank you, Deepak. Thank you, Shebam.
Are there any more questions, guys?
Oh, you're welcome, Tanya. That's very sweet of you. You're welcome, Piyush.
Great, great. So, Tyler, people have enjoyed your session a lot. Can already see it from the comments, which are not stopping at all. It's great to see. All right, folks, if that's the case, if we do not have any more questions, then I'd like to officially close the session. Thanks, Tyler. Thanks a lot for coming to Pesto and taking this session for us. And thanks to each one of you for joining in as well. It's pretty late here in India, but thanks for joining at 10 p.m. on a Saturday. So again, have a great weekend ahead, guys, and thanks everyone for joining in.
All right. Thank you, Shreya.
All right, thanks. Have a great weekend.
All right.